Jupiter. You ever have one of those mornings? it's just the way it is for me right now. All right. What was I saying? Oh, so I managed to shoehorn in the idea of the movie and the series Highlander yesterday. So if you don't even know what that is, you're fine. It's not a prerequisite for this course that you have watched Highlander. I don't like it. Say again. It should be.
It should be.
I can make it bonus that you write a report on Highlander. I like that. And how bad Highlander 2 really is. So we talked about this part yesterday. So a function, one of the fundamental things I want a function to be able to do is to make sense physically. So I want every input to be able to have only one output. Each input goes to exactly one output. Let me stop right there for a minute. Not a full minute. So the examples I gave were, if I throw a ball and I say 3 seconds later, that's my question, that's my input. 3 seconds later, where is the ball? I expect one answer, right? If somebody gave me 2 or 3 or 18 answers to where the ball is, I would say, what the hell happened to that ball? Who shot that ball? Who blew that ball up? What has happened? Are you guys with me?
In quantum physics.
Some quantum physics, some uncertainty principle. I love it. We're not going to go there. Don't freak out. So look at this. Here's an example that is not mathematical at all. These are types of cars that are made by different companies. So Ford makes the Edge. Chrysler makes the Town and Country, as far as we care about with this sample. And Chevy makes Trax and Equinox. I have no idea. Do they still make Trax? I have no idea. This is the domain. These are my inputs. So when you see the word domain, it really just means inputs. And range is outputs. Why is this not a function? I'm going to tell you right now. This is not an example of a function. What's supposed to happen for a function? Every input is supposed to have one output. So where does this sucker break down? Where does this break down?
Multiple models.
For what?
For each.
No. So, I mean, in general, you're right. But in terms of, let's say these are things I saw in the parking lot. That's my function.
Right? A Chevy.
Where exactly does this guy break down?
Chevy.
Chevy. Okay, does everybody see? The input of Chevy, how many outputs did it have? 2. So this is not an example of a function. What about this guy?
Yeah.
All right, now somebody else. Sorry, Fu. Somebody else. Why is this okay? Why is it not bad? Look at 2. Doesn't 2 go to 5 and 5 and okay, I lost the number here. There we go. God. This is a fantastic morning. I need to just go back to bed and start over. Oh, I'm so happy that my freaking dean didn't come today. All right, here we go. All right. Please put a little 3 there if you're following along. I don't know how it got chopped off. 1 goes to 4, 2 goes to 5, and 3 goes to 5. Why is that okay? Why is that still a function? Is there any input that goes to more than one output? Does 1 go to more than one thing? Does everybody understand what I mean when I say goes to? 1 goes to 4, correct? So 1 does not go to more than one thing. Does 2 go to more than one thing? 2 goes to what? What does 2 go to?
To 5.
Thank you. Right? Does everybody see that? And what does 3 go to?
Also to 5.
Okay, so this could be like at 1 second, the ball is at 4 feet high. and then it lands on a ledge 5 feet high. So now at 2 seconds, it's 5 foot tall. 3 seconds, it's 5 foot in the air. 4 seconds, it's 5 foot in the air. That's still fine, right? Okay, maybe. I don't know. Look at this example down here. Which part of this point, let's look at this first point. Which part is the input? Which part of this first point is the input?
The 1.
The 1, I love it. Input is X, right? Which part's the output? 10. So look at all of these together. Do they make a function? Again, how do you tell if something's a function? It's not a function if any input goes to more than one output. Does that happen here?
No.
Where does the, do you see what 1 goes? Doesn't 1 go to 10? And?
Oh, and 3.
Yeah. So it's like a cop asking me, where were you at 1 a.m. this morning? I was 10 blocks away and 3 blocks away. What? Who are you? What kind of mutant are you? X-Man. All right. All right. So that's the, oh, Jeff, why are you? It's amazing. The festivities of this morning don't end.
Kind of twisted me a little bit, Jeff, on that. When I was looking at the 110, I was looking for 2 numbers to be in back, that it went to 2 places.
But you can't. A point is an X and a Y, right?
Right.
So the deal here is I have a point that shows me 1 goes to 10, and I have another point that shows me 1 goes to 3.
Got it.
All right. I like it. Beautiful. So it's kind of like I could draw this to look like this, right? I got so much writing here. Let me take some of this away. All right. I got to bring my 3 back. Poor little 3. Come here, 3.
All the arrows made it look a flow chart.
Yeah, I know, exactly. So now watch. I could draw this. So watch this. What are all my inputs? 1, 2, 3, and -1. That's all my inputs from here, right? And what are my outputs? 10, 13, -4, and 3. 1 would go to 10 and 3, right? And then 2 would go to 13. Did I leave 1 out? I did. Poor little 2. 3 would go to -4, and -1 would go to 2. So you got 1 going to more than one thing. That's what makes it not a function. Okay. Now the most recent mistake I've made is I'm not using this tool to draw on this right now, which is really kind of dumb because I need to clear all this away. But that's all right. Most of this is just extraneous stuff. So I'm going to clear all these drawings away. Here they go. Pop. So mathematically, you can only be a function if there is no input that has more than one output. That's how you can be a function. The next level of this, so that's the basic definition of function. The next level is what do functions look like, right? So here's what a function looks like. And we kind of looked at this yesterday a little bit. Oh, Jeff, let's use the correct thing. There we go, buddy. Good job. And again, here's the note to try to help. For f of 2, which is the first question, right? They give me what the function is, and then they ask me what's f of 2, and that's how you read it, f of 2. The input is 2, which is the x value. The output would be the y value. Okay. So f of 2 Where do I put 2? What is 2? 2 is the x value. So I'm going to put 2 right there. So all this is, fundamentally, all function notation is substitution. The number they put in here is the number that I substitute there. See, isn't this say f of x is negative 3 times x plus 5? So what's f of 2? Negative 3 times 2 plus 5. I just substitute. So then I can figure this out. What's f of 2? It's negative 6 plus 5. So f of 2 is negative 1. So it's using new notation for something we've known forever. We know about substituting values in for variables, right? We've done that before. Can somebody tell me a point that this function goes through, just looking at this? What's a point that this function goes through?
Negative 1 and 5.
No. 2 is an input. So when 2 is the input, what's the output?
Negative 1.
So that's another bonus of function notation, is when I get to the end, I can actually read the point off directly. So you guys try part B. Let me erase some of this. I really do like to do like a football coach thing going on. All right. So again, the whole idea behind function notation is just substitution. That's all it means. So I'm going to rewrite this as negative 3 times 10. So then f of 10, what's negative 30 plus 5?
25.
Negative 25. So another point this function goes through is the point 10, negative 25. Can somebody tell me what kind of function this is? What would it look like if I graphed it? Oh, I got a chat. Yes, it would be a straight line. I love it, right? It's got a slope of negative 3. It's got a y-intercept of 5. It would just be a straight line. So what, do you guys see how the function notation is sort of like where you do the work and you see the point all at once? So you don't have to make like a separate XY table. You can just see the points in the work that you did. Okay. Another benefit of function notation is I can have multiple functions defined, and I can ask you questions like this and you know exactly which function to use. So I have an F function, I have a G function, I have an H function. Which one do you use? Well, you just look at the letter. So try 2A here real quick. Try to figure out what that is. Oops, where's that? Oh, there it is. Sometimes students get a little confused when there's more than one of the letter, but if I know that X is negative 3, I just put it everywhere there's an X. right? So this is going to look like -3 squared minus 2 times -3. What's -3 squared?
-9.
It's +9, right? Is this cool? Because a lot of people do that also, but I'm squaring x. And what do you get when you square a negative number? You get a positive number, because negative times negative, positive. And then the same thing happens here. What's -2 times -3? +6, and so I get 15. Okay. And again, I can see a point that the g function goes through is -3, 15. You guys doing all right out there? I keep asking that question, but what about part B? Can you do that real quick? Let me erase some of my writing here. Let's see.
I was kind of looking at it like we needed to bring like the -3 down and then divide both sides. So we just stop there then.
Oh, again, this means g evaluated at -3 equals 15.
Oh, okay. Okay.
Yeah, in fact, I really want this to make sense. F by itself don't mean shit. G by itself don't mean shit. It's got to be F evaluated at something. G evaluated at something. Right? So like I said the other day, it's sort of like saying the square root of x equals 9 and then dividing both sides by x or something. So you get the square root equals 9 over x. That doesn't make any sense. You can't do that. So it's not g times -3. It's g of -3. It's g evaluated at -3. So it's just different notation. It's just a way to show what's going on, a way to remember what I plugged in and what I get out. So what do you guys get for g of 1? So you put a 1 in. So I get 1 minus 2, right? So just put a 1 in. Everywhere I see an x, I put a 1. So I'm going to put a 1 there. I'm going to put a 1 there. 1 squared is 1. Minus 2 times 1 is -2. And 1 minus 2, -1. So the part we're not used to, so I really want you to notice this. Let me bring back this first one. Remember this? The first problem was this. What normally goes here for a line? What would I normally put here? I wouldn't put f of x. What normally goes over here? What equals mx plus b?
Y.
Y. I love it. So all this notation, all this piece is doing is taking the place of y.
Oh, it clicks. Okay, I get it.
All right, good. So, and that's the interesting thing about being a teacher is I have to kind of reach out and figure out what is it that I need to say and how, because we all think about things differently. So, and again, I want you, and again, let me go a little further with this. Stay with me now. Stay with me. Let me come up here. So what if I had a bunch of like y equals 4x plus 2, y equals 2 minus x squared, y equals 3 over x, y equals the square root of x. And I said, what do you get if x is 7? You know, like for what? You got 4 things here. Which one? So if instead of, stay with me now, if instead of calling all of these y, what if I called this first dude f of x, and I call the next dude g of x, and I call the next dude h of x, and I call the next dude, we don't like using I normally, let me use, it doesn't really matter, a of x, And then I ask you, all right, what is g of 7? Okay, now I know exactly which one to use. I use the g function. I'm going to put it 7 into this dude. I don't give a shit about the other ones right now. So the higher you get up in math, the more functions you're kind of dealing with. So I need a way to name them so I know exactly which one to use when. So instead of just using y everywhere, so that I don't have a clue which one you want me to use, I'm going to give them more specific names. And in fact, what if I had a profit function, a function that told me how much profit I'm going to make? I'm going to use a freaking letter P for it, right? What if I had a function for the number of bumblebees in my backyard? I don't know what that would be. Sure, I like it. The number of bumblebees in my backyard, I can use the letter B for bumblebee. Isn't that crazy? The standard ones to use are F, G, and H. And then beyond that, you can use really anything you want to. They're just placeholders, just so I know which one to use when. All right, how you guys feeling about these now? A little better? Or you're like, why do I need this in my life, Jeff? Well, because you're in my class. So try number 3 is a more interesting function.
I would have to say both. Why?
I like it. Sometimes we don't know why we need something. So you try number 3. See what you can do with that. It's a little bit funkier function. So again, I don't care how weird the function looks or whatever. The first step for function notation is the same. You just substitute. Because see how this says x is 5? I can see x is 5 because I replaced x with 5. So I do the same thing on the other side. I replace x with 5. And then that becomes nice, right? And that 3 over 3. So again, it goes to the point 5 comma 1. Okay. So allow this to become boring in a way. It's just substitution. And this is something we've done forever with algebra. Substitute values into variables. Ooh, that's the most basic thing about algebra. It's just that the notation we use takes a little getting used to. What about this? What happens with this guy? What happens when you try to do h of 2? Is everything great, or what happens?
No.
Things suck. What happened? You get 3 over 2 minus 2, which is 3 over 0. What's that?
You can't do that.
Yeah. Undefined. That just wants to remind you that functions don't get rid of problems we have. They're just another way to write things. So I'm still going to have values that might make my function freak out. Okay, I like it. So in this case, if I were drawing this thing, if I were graphing this thing, there would be weirdness at 2, right? This is actually, you guys remember, have you ever seen the shirt I wear with Gandalf and it says, "You shall not pass"? This would be where there would be an asymptote and the function would slam up against it like that. Do we have to know that now? No. I just want to tell you, if you see a thing where there's an undefined part of a function, that means the graph is going to look freaky there. That kind of makes sense. All right, now number 4 gets a little more interesting. Try to do all 3 of number 4. Let me see what happens. It starts off nice and then it immediately gets freaky. So I want to see what you guys think. Oh yeah, by the way, guys, remember yesterday I had to do the speech at the Senate? So the person running against me went first. And while she gave her speech, we had a major Zoom bombing incident. About 8 people suddenly came in and started yelling these horrible things, and there was some nudity involved. It was yeah, it was a little, and then I had to give my speech right after that. I'm like, what the hell? I have to follow that? So
That was awesome.
it definitely was one of the more interesting Senate meetings. There's no doubt about that. Yeah. Part A should be easy here, right? I just put a 0 in for X. For some reason, I always get somebody that there's still a 4 here, but what the hell is 4 times 0?
0.
Yeah, I don't know how people have that 4 stay alive. It died the minute it multiplied by 0. What do you guys think about part B? Does anyone think they figured out part B?
Four W minus 1.
Yeah. I'm sorry. I didn't mean to yell at you. So h of x is 4x minus 1. So, of course, h of w is 4w minus 1. Because, again, it doesn't matter. It does not matter what's in here. You just put it in place of that. So what's h of Nikisha?
3. Oh,
Sorry, I love that. That's so awesome. sorry. It would be 4 times Nikisha minus 1, right? Whatever the hell is in here, I put it there. That's all I do. It's so single-minded. It's so, and then I simplify it if I can. So what's different about this question? Can I go any further than this? No. There's nothing I can simplify. They're not like terms, right? So what the hell? Here, if you haven't tried this one out, I'm going to give you a minute. Go ahead and try this one out now. It's a little bit different, but it's the exact same idea. Exactly the same idea. Let me put up here. Oh. All right, does anyone think they have the answer? Nobody?
It's 4a minus 5.
Beautiful. So what am I going to put in place of x now? I'm going to put a minus 1. So this is going to look like 4 times a minus 1 minus 1. So I wrote 4 times x. Oh, but x is this. Minus 1. Isn't that a lot like substitution method? Remember that? It's exactly the same thing. It's just substitution. That's all it is. This guy tells me x is this. So where I see an x, I put this. And now I simplify, distribute the 4. So I get 4a minus 5. That's what h of a minus 1 is. Freaky shit. Okay. So you guys might, I mean, there's actually functions that will spell out the word love. Do you see how we get 2 letters for love? Have you ever seen that? Oh, math, trying to pretend like it's got love. Okay. But that's not the point of this section here. What was the definition of function again? Can somebody tell me real quick what the definition of function was for every?
One input.
For every input is one output.
Exactly. All right. I like it. For every input, there can be only one output. So what does that translate into visually? So here, is there an input that has more than one output on this picture? Probably the one I just pointed out, right? Or several. Doesn't every single one, this number, whatever that is, that's an input. How many outputs does it have? 2. So is this representative of a function?
No.
No. Too bad for you. So what is it that I can make visually then? What's the test? Vertical line test. If I draw a vertical line and it goes through the image more than once, that means that that input had more than one output. Isn't that beautiful? Does this pass? Is this a function? Is there any vertical line that goes through it more than once?
No.
No. So this is a function. Yay, it passes the test. What about this function? Anyone know what that function is, by the way? Anybody know what that function is? It is the absolute value function. Did you have to know that for this problem? No. Just pointing it out there. I like the fact that it's absolute value and it looks like a V. Is this a function? Huh? Sorry?
I can see it.
Oh, okay. Well, yeah, it is a V. So does it pass the vertical line test?
Yes.
Yes, it totally does. So this is a function. I kind of gave it away. I think I said absolute value function. So I sort of gave it away. What about this guy? Of course, that's the Zorro. That's the lazy Zorro function. Does he pass the, huh?
No.
Nope. Because right here, I can see several, oops, I missed. Good job, Jeff. I can see several vertical lines that go through. There's one that goes through 3 times. Damn. All it takes is one place where a vertical line goes through more than once. So it's sort of like a quick way to say that is, if I draw a function, it can't come back on itself like that. See, that would make it not a function, right? You can't come back on itself. Oh shit, am I using the wrong thing? I totally am. What is up? All right, has everybody got that? I'm not sure how much I've done with this here. Let me see. I'm gonna, all right, here we go. So everybody got that idea? Let me see what happens. Oh, I did it all with that. That's hilarious, Jeff. Okay. So I have multiple ways I can draw on something. And if I use the wrong one, then that sucks. Let's see. I'm not too worried about the rest of this. I actually put more than I needed to up here. Well, let's see. What can we do here? Yeah, I don't care about this too much. Let me see what you guys think about this. I like this last problem. Think about this for a second. Can you look at the graph and figure out what this is? Do I even tell you what the f function is? No. But I do give you a graph of it. Don't say anything out loud. Can you figure out what f of -1 must be looking at the graph?
Yeah.
Yeah. All right. Now, you think about this. The beautiful thing about a graph is it's all the answers. That's what a graph is, right? That's why I don't have to tell you the function, because somebody's already figured out all the answers. So what must f of -1 be? What must that be?
2.
Yeah. Do you see how the point, where's the input of -1 go? It goes to 2. So don't forget, when we calculate a value of a function, the input and the output is a point, and then I could go plot it. So if somebody has already plotted points for me, I could just see f of -1 must have been 2. That's why they put the points at -1, 2. So somebody else tell me what f of -2 is.
-2.
Yeah. -2 goes to -2. And of course, what's f of 5?
Five, 0.
0. I love it. Because it goes through the 0.50. So the output must have been 0. Kick ass. Kick ass. All right. I think that's let's see. I think this is enough of the functions. We don't have to know all of this stuff. Yeah, that's fine. And in fact, all of this is a little bit beyond what the book even requires you to know, but I want you to know a little bit more of the full picture of what functions are. Okay. So I want to go back to the book. Has everybody got what they want from this here? All right, let me stop sharing for a second here. Go back to the book real quick. All right, and this is section, oh, let's see, where am I? I believe, yeah, this is section 4.5. So remember in section 4.5, we have the idea of function in there a little bit, but mostly it's about exponential functions. So we did the whole thing about the form of an exponential function. Let me see here. Did we do this coffee one? I can't remember. I think we did. Yes, we did. The form of an exponential function that we're dealing with here was a times b to the x. Right? In fact, I think they have it in the book somewhere. I'm not going to find it right away. Where'd you go? Oh, well. I know they did. What's that?
Is it on page 519?
519, maybe. Let's see.
Well, I wrote it on the notes. I don't know if you just said it or.
I thought for sure they put it in here. Let me see. Well, they put it in here. Let me show you. They put it at the very beginning. Here. So that's the form of the exponential that we're looking at, right? So for example, one application of exponential functions would be A would be the amount you put in the account, and B would be the number that includes the interest rate. Like if B was 1.11, the interest rate is 11%, right? That kind of problem. So in any physical situation, the A and the B are going to have meaning in the real world. Okay. So let's see. I think I looked at the homework a little bit before. Yeah. Okay. I like it. So we're going to have now they bring up an idea. Remember break-even point? Break-even point is when we were learning about systems of equations. It was where the two lines, I'm sorry. It was where the one line crossed the x-axis. That was the break-even point. Right? Here we got something else called the crossover point. So I'm going to let you guys, so somewhere up in here would be where the crossover point is, and this kind of color coded here. Let you guys read about that. Let me see, anything else freaky in here? No, this is all about reading the graph they give you. They have a little bit about function in here. Okay. This is a little bit longer. I like this. This is a little bit longer homework. You guys are like, whatever, Jeff. All right. In case you forgot, I updated the homework sheet, right? So it's up on Canvas. And section 4.4 and section 4.6, I threw out because there were extra stuff I wanted to try to do, but it's getting close to the end here. So we're not going to have time for them. But I do want to look at, I think, did we do this last time? this stuff here, this should be relatively easy for us. Let's find out if that's true. Can you try number 1 and 2 there real quick? So this is the prep skills getting ready for section 4.7. So number 1 and 2 here. See what you can do with those. All right, how you guys doing out there? So to handle this 4.5, well, what'd you guys get for the perimeter? Anybody have the perimeter?
35 feet.
Yeah, 35 feet. Thankfully, they didn't sneak in any tricks with one of these being the wrong units, right? You always got to pay attention to that. So all you got to do there is just add up all the way around. So I would do 4.5 and 4.5 is 9. 13 and 13 is 26. 9 and 26 is 35. Bam. And of course, area involves doing what?
L times W.
Yes. 13 times 4.5.
58.5.
58.5. Okay. And what would the units be?
Feet.
No.
Feet squared.
Squared. I like it because it's foot times foot. And of course, area has got to be in square units because it takes little square pieces to fill an area. I like it. All right, what about number 2? That one is nifty. I really like it. So let's see if you guys can figure that out. So I'm really curious, how are you guys trying to figure this out? Is anyone drawing a picture? Is anyone using variables? What are you guys trying to do?
I just drew the picture. It's easiest.
Yeah, picture's a really smart idea. So I know it's 42 meters long. And then
I just put 42, 42. That's 4 minus 148 is 64. So I just split that in half.
I love it. Sure. And then you take 64 and you cut it in half because it's got to go across this one and this one. So you get 32. I like it.
32.
Now me, I would have been a total geek and I would have called these X and X. So then 2x plus 84 equals 148. And then I solve. And the funny thing is, all the math I do to solve this is all the math you did to solve that. So all algebra is a way to show all the steps that I've got to do together. But it's the same steps you would have done anyway, right? And this one, I don't need algebra for this one because there's not that many steps. Right, but algebra is not a bad idea, right? Okay, all right, I like it. That could be the name of the book I write when I'm older. Algebra is not a bad idea. Okay. So I'm going to clear all this away. We're going to look at the next section a little bit, and then we'll call it a day. Here we go. I'm going to clear all this away. Clear. Because the rest of this stuff, I really think you should be able to multiply that out, all that kind of stuff. This one's a little interesting. What happened to this drone? Somebody tell me the life story. This is the first day somebody got a new drone. I have a very sad story in my head.
The battery is about to start going out.
Maybe. So where did it start? What are the intercepts? What does that mean down here?
Started at 0,
0, 0.
Yeah, it's sitting on the ground at the beginning, right? And then it takes off, and he's like, "Oh, look at that! That's amazing! Look at it go! Wait! Oh, shit! All right, sorry. I see too many of these videos where, oh, I got a brand new $500 drone. Let's take it out. Yeah, looks great. Oh, it's dead. All right, well, dang. And so, what exactly does this mean?
fell at an hour.
Yeah, in an hour, it was back on the ground. It doesn't have to be a bad thing. It could have been he just brought it back to the ground. In my head, I see it crashing, but it didn't have to crash. Okay. That's not a big deal either, right? So the next section is going to be all about parabolas, all about quadratic stuff, right? And which is sort of like this picture kind of looks like a parabola that had a bad night, right? Like, but it still goes up and then comes back down. So it's like an upside down parabola. So in section 4.7, we're going to be dealing with equations that have x squared in them. And of course, they got to talk about Angry Birds, whatever. Because when you launch the little birdie, it goes on a parabolic arch and blah, 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 right? You guys have all seen that. That's all Angry Birds is an attempt to teach the masses about parabolic arches. Yeah, there's this thing, whatever. All right, so next time we'll get into quadratic stuff. The word quadratic. Anybody have a reaction when I say the word quadratic? What kind of reaction do you have, or what kind of memory does that bring up? Quadratic.
Just the term quadratic equation. That's it.
Okay, okay.
When I hear quad, I think of 4.
There you go. I love it. And one real quick. I love that you said that, Lino. I want to really show you why we call these quadratic. Stay with me. And remember, quadratic means the equation has a highest power of 2, right? That's what quadratic means. In which case you might say, well, what the shit is wrong with these mathematicians? That's not a 4, right? But watch this. If this side is x minus 1 and this side is x plus 2, what's the area? I would have to multiply these out. So one thing we're going to get into in this section is multiplying this out. I don't know if we've done this kind of thing yet. Have we multiplied something like this yet? Does anyone know out there how to do it? Does anyone know this method is called?
Distributing, right?
Yeah, I call it repeated distribution, but it's officially called FOIL.
Yeah, the first
Outer, inner, last, but that's
yeah.
bullshit. Just distribute the x. X times x is x squared. X times 2 is 2x. X times -1 is negative x. And -1 times 2 is -2. Do you see how that's squared? So that is officially, since it came from a 4-sided figure, they called it quadratic. Those old math people were high. They had a lot of stuff going on. So, but you can kind of see the logic there, right? Maybe. So we will be getting into we will be getting a bit more purely algebraic in the next few sections. So I don't know what that means to you, if that's a good thing or a bad thing, but it's just the reality. All right, I think that's enough. That's enough for today. So let me know if you need to ask me any questions. Otherwise, you're free to go.
So the test is on, the quiz
Tomorrow.
is on, what is it?
3-8 through 4-2.
4-2.
Yes. All right, guys. I'll see you. I'm going to head out. I'll see you all
Bye.
tomorrow. Bye. Maybe I'll head out. Here we go.